Okay, hello. We would like to show you some information about cloud rendering, especially hybrid cloud rendering. First, introduction. I'm a former rendering and shading TD. I've written shaders, for example, the volume shaders, which are implemented into Softimage. I'm the lead developer of the Wall Render team, and I'm honorary render farm administrator at the Film Academy in Ludwigsburg, right around the corner.
Yes. Hello. Yeah. My name is Jeremy Smith. I am the CTO of a company in London called Jellyfish Pictures, and we use Holger's software. And we've also spun up a cloud consulting part of our company. So, yeah. Just to give you a bit of background about Jellyfish, for those who don't know anything about us, we are 200 artists, technicians, and production staff. We have 4 different studios across 3 different spaces in London, and the type of work that we do is full CG, animation, visual effects, broadcast, 2D animation, and so forth. And over the years, we've won several visual effects awards, which we're really proud of. And just to give you an idea of some of the work that we're done, we're going to show our reel, and this was all rendered via raw render.
Yep. Before we start, we would like to know who is using the cloud already. Okay. And I assume everyone here would like to use the cloud. Are you a rendering supervisor? Are you working in rendering or a producer? So perhaps first the people working in rendering. Who's working in rendering? One. Okay. Producers? Around here? No? Okay. Okay, then we will continue. I've been visiting a lot of cloud rendering talks during the last 7 years, SIGGRAPH and FMX, and I was always missing some information. They just tell you, oh, cloud is nice, cloud is good, but no one talks about cost, about the issues, about what you have to handle besides the own starting VM machines, and so I created this presentation. First, some information about Wallrender. Wallrender is a render scheduler for 17 years now. We have been working closely with Microsoft and RenderWise to improve cloud rendering to cover all topics. And it's used for visual effects, feature films, commercials, any kind of computer-generated images. And it was built with the artist in mind and has features that you don't find in any other manager, like the uber-fast sequence checker, which loads an HD sequence in a thumbnail view within a few seconds, or the error checking for all the render errors. Who uses Wallrender? It's used all around the world. Perhaps you notice some companies like the game manufacturer Eidos, the design department of Mill, a space agency NASA, or World Wrestling Entertainment, or Lego Movies.
Yeah, and as mentioned earlier, we're Roll Render is now integrated with Azure, and so someone from Microsoft was supposed to be here on this presentation, but he wasn't able to be here today. But just to highlight, this is just some of the regions different around the globe, and so they have different regions and different geographical locations. So wherever you are, you can simply tap into that. And what's kind of new is kind of cool there. If you take a look at where Germany would be on the map, there's Germany and Switzerland. There's another 4 data centers that are set to being built. So if you're based within Europe. Yeah, this is pretty cool. And just to add some quick notes about Azure, and part of the reasons why we've decided to work with them is because they've got 71 different certifications and compliance, so they're very, very up on things like working with the film studios and the MPA and the CDSA and all that. And they've also, if you use things like the NVIDIA GPUs, there's a lot of them in there as well, and so we've used like the K80s, the P100s, and for our workflows. They also have a service called ExpressRoute, and what that is a dedicated 10 gig pipe directly into the Azure DC if you so needed that much bandwidth. So if you needed like a direct pipe into the cloud, I mean that is a pure private pipe that that's physically delivered on a cable to your premises, and that's how you can connect. And also, we've been working a lot with the head of open source for Azure within the UK, and just to reiterate that Linux is a first-class citizen on Azure, and all of our workloads for running, they're 100% Linux-based, so which is really, really cool. And we, just to make point to the last point there, we're a Windows-based studio on the desktop, but we've been working with Holger here in Roll Render, so we can do like a lot of the cross OS compatibility stuff. So all of our artists work on Windows boxes because they also like apps like Photoshop and Adobe. But when they go to do rendering, like say their Arnold or V-Ray scenes, all that's done on Linux on the back end. But from an artist perspective, they don't even know what OS they're using for rendering. So it's very, very handy.
Okay, next some information how you get started with cloud rendering in Wallrender. Of course, you need to create a source image. That's just like your default machine in your company. You have to install Maya or Houdini or anything you would like to use. And you need a network connection to the Azure cloud. This is done via VPN from your router, or Wallrender can create an open VPN server in Azure and connect via its own client, or you can use the ExpressRoute from Azure. Then you choose the VM type, how many cores, do you want a GPU, no GPU, and Wallrender can create the VMs with this information. Interesting is how many VMs should Wallrender start. At first you have a separated application, which is used by administrators only, because artists should not be controlling the VMs to start. You have a global limit for each cloud connector, which is the VM type we start. And then Wallrender uses two modes to decide how many machines it should start. It either can collect all jobs that you assign to the cloud and starts that many machines, or a manual mode, so you just tell Wallrender, okay, I need 10 machines right now at the moment. Wallrender creates everything required everything that is required in Azure, like resource groups, storages, copy the images. It creates the VMs, it starts the VMs. It does the whole system setup. It adds the VM to your domain, changes time zone, firewall settings, mount all shares. The Linux UMask adds an RDP user and changes the host file. So you don't have to set up the system anymore. And at last, Wallrender shuts down the VMs, either if they are idle for 3 minutes, or you have manual modes. The admin can say, okay, now I just need 5 and not 10 anymore, or you can just press the stop button to stop everything. So I will just show you some settings. So you have Wallrender configuration. Oh.
Drag it over.
Some configuration like the Azure login, and you can choose your VM. What kind of VM do you want to have, batch or non-batch? Batch has the opportunity that you can add licenses, so they have Maya, Arnold, or V-Ray licenses. 3D Max is added now, and they have low priority VMs. I will expand low priority later as well. Then the image file that contains your VM image, which kind of OS, the UMask, and the administrator account, and the renderer user. And this is the cloud manager. So you have all these cloud connectors, and I can just start another one. So I just say, okay, I need 10 more machines, and press start, and Wallrender will now create all VMs, and they will get online soon. No, I'm searching for the mouse. Mouse is gone. Oh, there it is.
Yeah, and just to say, so we use the batch service basically for CPU rendering and GPU rendering as well, because there are a few renderers out there that are really starting to take use of the GPUs, and this also includes V-Ray and Arnold. So it's good to know that this is for both types. So you can either use basically standard CPU rendering or GPUs. The other part of the cloud that we're really excited about is that we're working a lot with the guys from Teradici, and we're using their PC over IP protocol to deliver bursts of workstations. So in addition to rendering, the ability to spin up a workstation on demand and then have that user experience be delivered to anyone. And we did a really cool demo yesterday that kind of showed that off. And so what you see here is a small photo there, and that's myself on a plane doing a PC over IP session to a VM running in the cloud, and that's also running apps like Max, Maya, After Effects, and in addition, that's us managing our render farm from mid-flight. So it's really cool stuff, and it gives kind of the new meaning to working in the cloud. But we just kind of really want to push the protocol and just to kind of really just see what it can deliver. But this is the sort of like area of time that we're now living with in the visual effects and post-production world. So it's really cool. And just at Jellyfish, we are very much using a hybrid model. And so when we went to the cloud, we didn't want to not stop using our on-prem resources. And so for us, we wanted a way of seamlessly extending our infrastructure. And so all of the VMs that we have running in the cloud, they're using the same render environment. And when I say that, that means they're authenticating against the same things like Active Directory and our actual domain. And so things like ACOS permissions and certifications and all the rest of it, that's still intact. And it's using exactly the same build of V-Ray and Arnold that our current pipeline on-prem is using. So they're not really like duplicating any effort. And when we extended our workflow and our pipeline to the cloud, I mean, our pipeline guys didn't really have to do much of anything because it's just like natural elasticity. So it's really, really cool. And then obviously down to point two is that we're able to save costs, and we'll go into more, or Holger will go into more about this later. But obviously we don't have to over provision for a single job to get a job out the door, and then have all of these like Dell or HP blades just sitting there potentially doing nothing. So for us, that was the key, and so the hybrid model for us makes it very, very attractive. And just give me 1 second here.
Oh, 1 second.
I'm just over the Wi-Fi here, so its latency's not. So I was trying to disconnect and connect again. Yeah, okay. That's fine. Okay. All right, so what we see here, basically, if you take a look on the left-hand side here, these are actually different blades and different resources that we have on premise. And you'll see this other group here called cloud, and what that is, that's actually up and running live on the cloud at the moment. So it's for us to, the cloud is just basically a natural extension of our render management, essentially. So say, for example, if we were to take a job here, we can allocate it to the green items here. They represent like the blades that they're running on-prem. But if we want to basically assign that to Azure, we would basically tick that and hit assign. And we'll go from there, but the Wi-Fi is bombing out. So, but you see, that's as simply as easy as it is for us to assign a job to the cloud, and then basically things like proprietary shaders pick up, our custom pipelines, any shotgun integration that we've done. So our workflow remains exactly the same. There, and you can see now it's highlighted in green because that job is now assigned for rendering on-prem, and then it's now assigned to basically rendering in Azure. Now, if you take a look at this here, if I can show you. This is on the batch service here. So basically, when we were upstairs, when we came down, we basically spun up 640 cores, and then Holger a little while ago started those other 10 VMs. And as you can see, their current cores, there's 2 pools, and each pool has 640 cores. So that's roughly 1,200 cores that we're able to spin up in about, 10 minutes, 50 minutes of that. And so the speed of provisioning is basically like nothing that you would ever get on premise. And so, I mean, this is a live demo of us actually doing it here. And so that's 64 threads per VM. And so, I mean, that's a lot of grunt compared to our on-prem stuff. So, and we're actually finding that these VMs are about 3 times quicker than our Dell Blade chassis. So, yeah.
So next topic are the advantages and challenges. First, you have different kind of licenses. There are buy your own license, which is what most of you are doing right now on-prem. You buy licenses, either permanent or rented. And they are limited by the number of licenses you have bought. And there's metered licensing. And metered licensing pays, you have to pay for metered license per hour. There are 2 different types, prepaid, so you buy amount of hours in advance, or postpaid, which is done in Azure, so you assign a license to a VM and you get billed at the end of the month. We have some example. One vendor is metered prepaid. V-Ray has a postpaid way via Azure, and Autodesk has changed their license, so you can now use software that is on subscription in the cloud, and you can as well order licenses on Azure. Next big topic, security. First, for a secure environment, the underlying system has to be secure. So the Azure data centers have to be secure, and Azure itself completed the formal assessment by the MPAA, and Azure has been validated by the CDSA, and Microsoft is committed to continuing the annual CDSA audits. And side note, the military has approved data centers as well, so it's really secure. They have higher standards than the MPAA. Secondly, your CGI company needs a separate audit. So the whole system you have set up needs to be audited. Jellyfish Pictures was approved to use the cloud, for example, and this is brand new. MPAA and CSA have teamed up to launch TPM, which is the new partner program which will audit your companies in the future. And they try to prevent the leaks that have been happened in the last year with this new partner network. Okay, security. First, you have your on-premise company. You have an open internet area, which includes the cloud manager and your email clients in your company. You have a firewall to your work area, where your file server, the R server, and the license server is running. You have a gateway, which is your router or a separated dedicated machine. This one sets up a VPN. The VPN is encrypted with 256-bit. And on the other side, you have the cloud. But the cloud is not just open internet. It's an Azure data center, and this data center has really high standards. I would assume that this data center is harder to hack than your company. So you have a secure connection from your company to the secure data center, and on top, you have the green area, your domain settings. Because it's just one big network, all your machines use the same domain settings, the same user rights, and your data is safe from internal from internal hacks as well, because the users cannot access data they are not allowed to. The next challenge is the data transfer. Of course, you can just spin up a VM that connect to your file server, but it's really slow because every VM copies the same data, and it's just slowing down your whole rendering. You're paying for VMs that just try to copy data. You can manually copy the data to the cloud before you start rendering, but this is a lot of work. The best way is the fully automated way. You have a file server OS in the cloud, and this OS copies all the data once it is requested by a VM. There are a few types available, for example, GPFS server via Pixel Media, and Microsoft has just bought Azure, and they offer synchronization solutions as well. And this is the best solution because you don't have to care about data anymore. You just spin up the VMs connect to the file server in the cloud, and the file server copies the data and can distribute the data to many VMs.
Yeah, so when we just want to talk about one of the advantages of speed of provisioning. So as you saw in the demo, we're able to spin up 1,200 cores in a very, very little time, and so that is a major advantage is just the sheer raw of speed. Because if you wanted to try and do that the old school way, I mean, it would be days or weeks, calling Dell or HP, getting them on the phone. Another advantage is basically just the sheer scale that you can actually hit basically when using these types of services. I mean, So you're not talking about like 1 or 2,000, but I mean, there's people out there, like 10 or 20,000, and it's just to hit those sort of numbers and that quickly is absolutely phenomenal. And so, you can pretty much hit a massive amount of consumption. So after an hour goes by, you could have like one of the largest render farms in the EU, for example. And the other advantage is that you can custom tailor your VMs to basically just different workloads. So say, for example, if you have one job or one render or one simulation that's taking like a lot of memory, you may want to use a different VM size. But as Holger kind of showed out earlier, that's as simple as basically setting a different VM in a drop-down box and hitting go. And so therefore, you could have like say 500 gigs of RAM compared to 64 gigs of RAM, for example, for that specific job. And there's no picking up the phone. There's no running to the hardware store to try and find like RAM DIMMs and all that sort of stuff. So I mean, all that sort of thing we feel will be a thing of the past as time goes on. And some of the benefits of this is just some examples. It's no overtime or late night working, and so we've regularly had compositors basically kind of like sitting around twiddling their thumbs till 4 or 5 in the afternoon waiting for the 3D renders to finish. And then really like the comp artists, they only really start their day at like say 4 or 5 in the afternoon, then they end up having to work late. Then obviously that makes for disgruntled employees and so forth and so forth. And so I mean we're able to basically finish all jobs within the deadlines that we need, which is obviously makes clients happy, makes our staff happy. And we'd rather keep our staff busy working on shots and sequences rather than basically waiting on renders to finish and progress bars. We could also basically bid and accept jobs with tougher deadlines. So for example, when we're doing work for Netflix, all their stuff is a minimum of 4K and soon to be probably 4K HDR. And just for us to do that on our current farm would take quite a while. And also, we've also had clients that want their rendering deliverables pushed up by a few days. And so, if you want, so we can get this done sooner, but there is going to be a cost for that. And so we can burst onto the cloud for that. And if you're happy, we're happy to do that for you. And a lot of times they should just say, yes, we just need it now. And so therefore we do that as well. And it just allows us to work on 4K, 5K content with ease. So we're not worried about how our internal farm is gonna handle really. And what does it mean for studios? So what does it mean for people like Jellyfish? We can cut our costs by not over-provisioning for a job. So the idea of doing a panic purchase to deliver like one job that's going to be out in like say 2 weeks, we don't have to worry about that because obviously if we were to buy those additional blades, we would have to worry about keeping them busy after the job is delivered, and sometimes that's not always the case. We're working in an OPEX and not a CAPEX model, which also helps really improve cash flow. So we only have to spend the money on cloud resources when the productions are only being signed off and commissioned. So, it really ties us in to hug that curve a lot easier. We can ramp up and down as production requires. So we've talked about speed of provisioning and scaling and all the rest of it, but one thing that's really, really important is the ability to scale down when you're done. And so, when you're done with those renders, you're done with those workstations, you don't have to worry about an ongoing cost because that resource is gone for that job. And obviously things like power, air conditioning, rack space, we don't deal with that. All we deal with is a single cable coming into the building and that's it. So aircon, electricity, power outages, we just let the guys at Azure deal with all that, and that's not something that should be considered. And as I mentioned up earlier, we can ramp up CPU and GPU jobs for 4K workflows, and this includes GPU rendering, simulation, and so forth. As well as CPU, so it really depends whatever your workflow is. And obviously we don't have to basically rack this stuff in central London because London is one of the most expensive cities around, and it's crazy to put all this servers and physical kit in one of the most expensive real estate places on the planet. So it's, one sense it's kind of out of sight and out of mind. So we don't have, we'd rather put office desks there. So those are just some of the advantages.
So the last topic are costs, because you're all interested in the costs. For producers, it's viable to know there can be a limit. So you can control the costs via Azure. You can set a core limit. You can automate shutdowns. You can send email notifications or create your own tools that access the billing API to control the cost in your company. To explain why the cloud can be cheaper than a pure on-premise render farm, I have to explain a little bit more. This is a typical project. If you would have as many machines to render all your shots within a few hours, it would look like this. You have a starting phase where you do some shading tests, then you have main rendering, where you hit your limit, and the end phase. And because you don't buy as many machines that you can render everything within a few hours, you clamp the number of machines, but then you have to wait days for your rendering. So everything shifts further to a later deadline. But you could use the cloud for just the peak. So use the cloud only for a short time and render everything else on-premise. Then there are people, no, we have multiple projects, we don't have any unused time. Perhaps your workload looks like this, but you still have unused time on some machines. Perhaps not all machines are used, not used all the time, but as you can see, you still have peaks in your render farm. Second is, we have to calculate how much we spend on the cloud. Right now, you do exactly the same calculation. You calculate, okay, what's my render time? Can I finish all frames until the deadline? And you use this calculation and convert the time into money on the cloud. But the difference is, on the cloud, you can spend the money in 1 month, you can spend it in 1 week, or over the weekend for the deadline on Monday. So you have full control over the time until the rendering should be finished. Thing is, on-premise machines are for free, and the cloud costs per minute. But on-premise machines are not for free. A lot of companies are buying new machines after 3 years, and yes, the cloud costs, but it only costs if used, and you don't use it all the time. And you forget all the additional costs. Power, room, network infrastructure, system administrator, air conditioning, downtime if a machine breaks, and the larger your render farm, the higher your costs are. For example, if you have 5 machines, you can just put it into any room. If you have 100 machines, you need the real expensive air conditioning. But let's imagine, because on-premise machines are for free, you tell your producer next week, we just buy 40 new machines. Or 120 machines, they're just for free. Or 400 new machines. Then your producer would say, no, they are not for free. We need a lot of money to pay these machines, and we don't need these machines. We have just paid for a lot of machines we don't need at the moment. So the cost difference is on-premise costs if you don't use the machine, and the cloud costs if you use the machines. And one of the other topics is Azure low priority VMs. Azure has introduced these VMs about half a year ago, and they have the exact same problem as you have. The machines cost if they are not used. So Azure allows you to rent these machines that have not been rented by anyone else, and the machines that are reserved in case of hardware failures, and offers these machines for a huge discount. 80% discount for Linux VMs and about 60% discount for Windows VMs. But a small explanation why the cloud can be cheaper. We just do a tiny company calculation. You only have to pay power, no room, no network infrastructure, no air conditioning, nothing at all. And if you now compare the costs of a machine on-premise with a VM in the cloud, we have done that last month with a 64 hyper-threading core machine, then the on-premise machine is a bit more than half the price of the cloud machine if you let both run for a whole month. If you run both for 70 days, they cost the same. And if you run it less than 70 days, like 15 days, the cloud gets cheaper than on-premise machines. The less you use the cloud, the cheaper the cloud gets compared to on-premise machines. So you see, the cloud can be cheaper than buying a lot of machines in your company. It just depends if you use the cloud for peaks only, or if you use it for a lot of rendering. And you forget all the additional costs for the on-premise machines. So the on-premise machines are in fact more expensive than in this example. Last example, 3 years ago, we have spin up 624 VMs, 10,000 non-hyper-threading cores, and we have been running them for the whole presentation for 1 hour, and it has cost us 1,000 euro. But with the new changes in Wall Render, that Wall Render can convert Maya scene files, it's the only render manager that convert that many Maya nodes like Arnold volumes or color management and all this information. We have now switched to Linux, and we switched to these low priority VMs. And if we would now spin up all these machines for 1 hour, it would cost us about 100 euro. So that's a huge price drop compared to a few years ago.
Yeah, I'll just quickly add the VMs that we spun up for this demo today. So 1,200 VMs is in euros. It's about 14 euros an hour for about 1,200 cores. So I mean that's pretty phenomenal. So yeah, and just to say that we've spun up a consultancy company to help others get to the cloud if they would like to take their workloads to the cloud. And if you're interested, that's something that you can just chat to us about after. If you would like to help getting there, yeah. So just we'll be free after.
At last, I would like to invite you to our Wall Render Carousel. It's starting tomorrow at 5 o'clock in the afternoon. We have already ordered 500 burgers, so the first 500 people would get burger, and we have ordered some beer. Microsoft and NVIDIA have spent some money to order more beer. And yeah, I would like to see you there. And if you have any questions, just ask us now or later via email or phone.
Yeah. Well, we have a bit of time here. I mean, if there's any questions, I mean, we're happy to take them now or chat after. So. Yeah.
It seems the presentation works well if all questions have been answered.
Cool. All right then. Well, thanks for coming, everyone. It's great to see you all. Thanks again.